For the series of the cosmological perturbation, later we talk about the various one. First of all, we discussed the perturbations in the Newtonian limit, and second we turn to the GR boson, and we turn to the superhorizon limit on the adiabatic condition, and next in the last time we talk about the perturbations of the matter component. Today we talk about the cosmological perturbations of the radiation component, especially the radiations will couple to the baryonic matters, so the baryon Photon fluid will be discussed. So in the figures below, this show that the overall behaviors of the density perturbations of the photon, baryon, and the cold dark matters. And the transition from the radiation to the matter dominations occurs around the 10 to the minus 3 for the last shift. So in this moment, before this, universe is in RD, and after this, universe is in MD. And during the RD, the cold dark matters that perturbations grows as logarithmically. After the matter domination, it follows the linear growth, like that. And after the decoupling between the baryon and the photon, baryon follows the cold dark matters, the density perturbation. And due to the oscillations of the photon perturbation, so it influences the baryon acoustic oscillations in the power spectrum. For the case of the perturbations, it oscillates after the specific K modes that enter the horizon south. But there is a radiation process due to the one of the orthic calcium site. It gets oscillation behavior. And after the decoupling with the baryonic matters, the photon perturbation becomes negligibly small. It decays over the scale factors. So the such a different behaviors between the cold dark matters baryon and the photon components determines the structure formations from the power spectrum, and also the traces of the acoustic oscillations in the baryon, especially the cosmic microwave backgrounds of the photon radiations. So this is the overall behaviors of the density perturbation for each component, and today we will focus on the radiations perturbation and the photons one. The radiation perturbations that depends on the also similarly to the universes in the RD or MD, and whether the specific K mode is in the inside or outside of the horizon. For the super horizon regime, the outside of the horizon, we will impose the adiabatic initial condition here. The radiation and the matter perturbations are related to each other with just a coefficient. It's a lot discussed in the when we talk about the adiabatics, the initial conditions in previous time, and also the superhorizon modes. The gravitational potentials, the constants for each RD and MD era, and the Einstein build equations, they give the constraints between the gravitational potential pi and the radiation perturbation. So the point is for the superhorizon case, the radiation perturbations that remains approximately constant following the gravitational potential. But for the cases of the subhorizon, inside the horizons, the density perturbations evolves. The equation of the motion for the radiation perturbation from the conservation equations are the following. Already we discussed the the dynamics determined by the gravitational potential in the right hand side. And during the RD, the universe is dominated by the radiation component, so the speed of the sound is given by the one of the third. And after the specific moves are enter the horizon side, then the dynamics obeys the following equation of the motion. Since the right hand side, the gravitational potentials decays the sub-horizon during the RD, so the right hand side becomes 0. And the solutions of this equations are given by the just harmonic oscillation form, depending on the HK mode. So the radiation components during the RD with the sub-horizon show that the oscillation behavior with the slow decaying amplitude due to the expansions of the universe. Such oscillation behaviors arises from the process. The process balances the gravitational growth, which comes from the non-zero speed of the sound. For the case of the MD in the superhorizon regime, the dynamics is changes because the gravitational potentials are not decay, and the radiations are no longer dominates the background, so the external potentials with from the matters arise. So the right hand side of the non-zero terms of the gravitational potentials are arising from the matter component. The solution of these equations are also boosted by the balance between gravitation impact and quantum process impact. But the radiation density, the background ones that relative as h at minus 4, so its perturbations are dramatically negligible, almost decays in the late time. So the radiation perturbations never grows during the MD, and they always convert to the gravitational instability leading to the acoustic oscillation. So this is just the overall story of how the radiation component get the density perturbation behaviors for the superhorizon, subhorizon, and RD and the MD approach. And photons, the radiation components, couples with the baryonic matter before the recombination, so it tightly relates with the matter's density perturbation. The interactions are given by the Thomson scattering between the photons and the baryon. The interaction rate can be represented by the number density and the cross-section. And we'll assume that the photon and the baryon share the common velocity here. So that this can be treated as a single Photon-Baryon fluid. The total densities and the projects are the following. There are no contribution from the matters for the projects. The effective sound has also got the correction because in the denominators, the energy density and get the contribution from the baryon, which is represented by the capital R for the ratio between the baryon and the photon energy density. In earlier times, the photons energy density is dominant, so this ratio capital R is extremely small, so the speed of sound is just reproduces one of them. But around the recombinations that approach the capital R, this ratios grow because the baryon number density energy density is similar to the photons one, so the sound speeds will be decreased. So under such a tight coupling between the baryon and the photon, the equations that becomes a combined perturbing behavior. So here the delta RB represents the single baryon photon fluid. During the RD, the gravitational potentials decay, so that it gets just acoustic oscillations to the behavior. Where here the RS represents the sound horizon at the complement time eta, but integrates the speed of the sound over the complement time. But during the MD, the gravitational potentials approximate the constant for this right-hand side, so the acoustic oscillation produces imprints on the CMB. So the each extremums of the oscillation here, for example, the C and A, the extreme of this oscillation of the delta R, gives the peak, and the zero amplitude of the during the oscillation gives the drought. So the such a position of its peak over the power spectrum, and also height of the peaks are strongly determined by the information of the sound horizon, is Rs at the decoupling moment, and also the amounts of the matters, how the cold dark matter and the baryons are built in the universe. So the such a position and the height of the baryon acoustic oscillation peak in the CMP power spectrums can provide the information of the decoupling moment and the CDM or matters composition. And at the recombination, now the photons and the baryons are decoupled. The Thomson scattering rates are dropped below the Hubble, and the tight coupling limits the breakdown. The photons are decoupled and the start of streaming without the other interviews. And now the acoustic oscillation patterns are bosons in the CMB power spectrum, and the baryon lose the projects, so it follows the dark matters density perturbation as shown in the burst figure here. So how the such acoustic oscillations of the Photon-Baryon single fluid can influence the observable spectrum, especially the matters perturbation. When the some primordial rubber densities are forms, the gravities surplus the coupled fluid, but the case of the radiation, the content project drives the outward propagating force. So the acoustic oscillations are balanced between the such projects and the gravity. And this acoustic oscillations has some specific physical quantity which is called the sound horizon, RS, as the integrations of the speed of sound of the complement time, and this was frozen at the approaches of the recombination, which is the decoupling of the photons and the baryon. And when the structures are formed over the cosmic history, the galaxy prefer the form at the such overdensity, which comes from the acoustic oscillation, and the radius correspond to the bosons downwards. So this is the spectrum of the density perturbation, and some specific scale of the radius correspond to the sound of the horizon RS. There will be the primordial overdensity form. So along these stars, the galaxy stars will be generated, and this stars are given by the 2-point correlation function, R as order of the 150 megaparsec, as a sound of horizon scale at the recombination approach. And by the Fourier transformations of this 2-point correlation functions, one can obtain the power spectrums in the momentum or frequency space. This will give the baryon acoustic oscillation, briefly the BAO. In the Fourier space, the power spectrums can be defined as the scales of the matter perturbation for each K mode. And this power spectrum can be written schematically with the transfer function and the primordial spectrum. And these transfer functions include the information of the Photon-Baryon oscillations with such a form. And the amplitudes are determined by the fractions of the baryon and the cold dark matter. So the important point is a BAO, the acoustic oscillation, can provide the standard rulers in the cosmology with the various information. The sounds horizon at the recombination determine the early universe physics and observes the clustering scale of the galaxy, and this determine the lifetime expansion history due to the Hubble parameter. So by the BAO, one can determine the fractions of the cold dark matter and also for the other composition. So in summary, the evolutions of the radiations and the baryons are connected together. We talk about how the radiations, density perturbations, that goes over each cosmic approach, for example, the RD or MD. And the radiation perturbations show that the acoustic oscillation behavior due to the balance between the gravity and the quantum projects. And after the recombination, the photons and the baryons that decouple, and the information of the such acoustic oscillations returns out in terms of the sound horizontal at the recombination. This will give the early universe baryon acoustic oscillation (BAO), which gives some characteristic size scale of the cluster and the galaxy, and this can be determined by the sound horizon scale of the recombination. So today we talk about the radiations and the photon. I mean the radiations and baryon matter fluid and its evolutions. And maybe the next time we will continue with the discussion on the some initial density perturbations. Uh, can how can this how can how this can be generated from the pre-modern impulsion.